Innovations inevitably have consequences, and one of the consequences of our increasing reliance on technology has been an increasing use of energy. How are we going to deal with this? How are we going to provide new energy? Is it nuclear? Is it solar? What are we going to do with the energy required to transmit data, to store data, to compute? And where does the heat go after? That's the question for the panel on this episode of the Tech Field Day podcast. Welcome to the Tech Field Day podcast, where each time we meet, we bring together a group of technical experts from our Tech Field Day community to discuss a single concept. This podcast features a variety of perspectives from members of our Tech Field Day community, and today we are actually recording it live at AI Field Day in San Jose, California. It is currently January 2025. We have talked a lot about AI for the last week, but one of the things that didn't really come up as much as I think many of us would have liked is the question of power consumption, pollution, basically the fact that, or the oft-repeated thing that AI is burning down the rainforests and consuming as much energy as, I don't know, Ireland, pick a country, right? But it's not just AI, it's all of modern society. We're electric now, we're building dams, we're electrifying the whole darn state. And what does that go to? That's the topic of this episode of the Tech Field Day podcast. Before we begin the conversation, let's meet who's on the show.
Hi, I'm Jim Czuprynski. I'm a technical consultant, and I'm from Chicago, Illinois.
Hi, I'm Jack Pollard, Principal Analyst with Paradigm Technica, focusing on cybersecurity and AI.
Hi, I'm Andy Banta. I'm an independent consultant covering all sorts of technology issues.
And I'm Stephen Foskett, organizer of the Tech Field Day events and frequent pundit on things like this. So this is an area that I talk about a lot on the TechStrong gang. For some reason, they have me pigeonholed as the guy who will come on and talk about renewable energy and green power with Bonnie Schneider, because every week she brings up another positive and hopeful green story, and everybody shoots it down. I try not to. I think that we are actually looking toward a positive green future, despite the fact that power consumption just keeps rising. But I wonder, do you guys agree?
Yes and no, where I think that we are coming up with new green energy sources to cover an awful lot of the new demands that are coming up. But there's also the new power density of devices is incredible. This is a topic that came up last year at one of the field day events, where one of the vendors talked about having 120 kilowatts in a rack. And since then, I've heard discussions about going up to like 400 kilowatts in a rack. That is a huge amount of power. And they're even talking about having 400 volt buses in the racks to cut down the amount of copper that's needed in them. So we're talking about incredible amounts of power usage. There's another topic that was discussed in one of the conferences last year was that roughly a fifth of the power in an electric car goes into the data systems rather than motivating the car. And this is another example of how much power is getting consumed by data systems for a variety of different purposes. I've done a bunch of research on a lot of these different topics and have quite a few things to talk about, but I don't want this to be a monologue.
Well, I'll say that the power density is good, right? It is really good to get things as dense as possible from a power consumption. The challenge we now have is getting the power to the computing equipment, right? So we can build data centers. It's very easy to find cheap land out in the middle of nowhere. It's very easy to get data to those data centers. Laying fiber optic to them to get the data there is easy, but getting power to them is a big challenge. And what I've heard is that data center reservations out to 2027, 2028 are okay in terms that we've figured out how to get power to those data centers. As people are looking and building data centers out past the beginning or middle of 2027, they can't find enough power to power those data centers. So have we really run out of power? And what are we going to do? Because we need more and more and more compute equipment.
Yeah, and that's an interesting point too, Jack, that I'm an investor, full disclosure, in a company called NewScale, which I was really excited to invest in because it's small modular reactors, right? And Bill Gates, for example, for some of the Microsoft data centers, has been talking about using these small modular reactors. They have a different version. The one, NewScale is actually liquid cooled, but they have a newer version of this that's actually liquid sodium cooled. So super safe. None of the 3 Mile Island concerns that people had, though recently to power a data center, they were discussing about, since it's still licensed, reactivating part of 3 Mile Island to actually power the infrastructure for a data center. Right. So the power utilization curve, that sounds very Star Trek-ish, is not changing. It's certainly accelerating. And back to your point about getting the power to where you need to get it, right? Many people don't know this about the U.S. power grid, but there are disjoint parts of the U.S. power grid, and it's extremely difficult, in fact, almost impossible, to shift power from outside of Texas into Texas. And this is something that we were kind of on a trail to re-electrify our country. Who knows what's going to happen as a result of that, but imagine if you could ship power much more effectively.
Well, Stephen started out the conversation talking about green power, and I believe the greenest power is nuclear. I'm 100% believe it. The challenge we've always had is there's a huge fear factor around it, which you brought up, and there's a huge regulatory factor around it. So
Yes.
Yes, Microsoft invested and said they're going to invest billions of dollars in restarting 3 Mile Island. That's still many years away, and the belief is because of the regulatory hurdles and the fear factor around nuclear, that as small modular reactors are not years but decades away.
Yeah.
Well, I also think that solar presents as a greener option than nuclear. Not that I have any problem with nuclear power, but I want to get back to the IT side of this problem, where yes, there are issues with getting the power to the data centers, but the data centers themselves are producing a huge amount of heat.
Yeah.
And this is a matter of, you need to dissipate the heat somewhere. People talk about liquid cooling servers, and that's cool, but the liquid has to go somewhere to dump the heat.
Yeah, they're talking about geothermal cooling for liquid cooled servers.
Right. And there's a couple of different topics here. There's a company that I won't name that is in the Bay Area, probably not too far from here, that has essentially a 2-story cooling tower out behind their development plant, because that is what they use to cool their data center. And this is essentially dumping heat into the center of a heat island already. That
so what you're talking about is dumping heat into the atmosphere.
Dumping heat into the atmosphere, absolutely. And another thing that was brought up by somebody I talked to from Switzerland is that in the EU now, new data centers are not allowed to dissipate their heat into the atmosphere.
Yeah.
Existing data centers can, but new data centers have to figure out some other way to dissipate their heat. And there's a place in France where they're using it to heat a swimming pool. There's places in the Nordic countries where they're using the heat to, basically pump into the heating system for the town. But at the end of the day, even if we're carbon neutral on how we generate the power that goes into these data centers, we are still producing heat, and that heat is going to be causing issues, especially if it's dumped into heat islands already.
Yeah. And that's a really interesting point, because there's basically the energy has to go somewhere. So there's a couple of things here. So first, there's generation of electrical energy and how we're doing that, whether it's coal or nuclear or one of the green renewable sources. I will point out that photovoltaic solar panels, the learning curve for them has held steady at about 44% per year for the last 20 or 30 years, which means what that means in practical terms is that you are getting a little less than half as much energy per dollar from solar as you did last year. And that's caused really strange economic impacts where it's almost like a deflationary curve where it makes sense to wait another year before you buy your PV panels because they'll be so much more effective or so much cheaper next year. It's a really weird situation, but essentially those panels are being produced at such massive scale too. You can't put that genie in the bottle. It's already cheaper to buy solar panels than it is to just continue to feed a gas-powered turbine.
Yeah.
So I feel like solar is just going to happen. But what you say is absolutely true. Then what?
Any power you put into a data center produces no, in the physics terms of things, work. It's every watt you put into a data center turns into heat.
And you got to do something with it.
But see, here's where it gets interesting from a IT technology perspective is these are civil engineering problems, unfortunately. When you look at the actual compute boxes themselves, right? We can stuff more and more transistors on a chip and make that chip lower power consumption and do more inside the chips. It's moving the data off the chip. It's the IOs where the power is.
And absolutely, I mean, that's actually that's part of what's driving some of the density. That's where we're ending up with these densities of 120 or 4. And there was a presentation at Open Compute Project Summit last year where one of the people from one of the networking companies essentially said that they fear that over the next 5 years, fiber optics are going to consume $7 billion worth of electricity.
Well, absolutely, and it's a huge amount. But then when you look at, for instance, we're here talking about AI. When you look at a rack of equipment, right, for AI, right, the communicating between components in the rack, box to box in the rack, you can use copper because it runs efficiently at short distance, right?
Right, you can run it at very low power compared to the
fiber optics, driving the lasers.
Which is why they're trying to cram things into a tighter and tighter density. And you're right, they can run it at a lower voltage. And the same discussion just drew a distinction between active copper and passive copper, and part of what you need to think about here is that on the serial links, you need, even if there's nothing being carried over a serial link, you need to continually keep an idle stream going to keep the parity proper on that stream. So even if you're not carrying any data, that serial link
fiber optic is still being used.
Fiber optic and copper.
Still using energy.
It's like an elevator, consumes power to go up and down empty as well as it does full. Because
except in this case, the elevator has to, so essentially has to keep moving no matter what you do, and you have to keep the electronics, the copper bits moving, even if it's not carrying valid data. Right?
Exactly, and they do the distinction between active copper, which is what I just described, and passive copper, which you can essentially turn off if you're not transmitting any data.
Interesting.
And it was, I'll have it included in an article soon, but it was a very nice layout of essentially how much power is being consumed by passive copper, active copper, and 3 different fiber optic technologies along the line. And as I said, their estimate was $7 billion worth of electricity in 5 years.
And so there's a flip side of this discussion as well, and that's that advances in semiconductor manufacturing don't have to be used to improve performance. Exactly. They could also be used to improve efficiency. And so we were talking earlier about the incredible things that are happening in the IoT space with, I was bringing up the ESP32, which is just an incredible little microprocessor that can run on battery power for months at a time. It's got a full TCP stack. It's got an ARM processor. And it basically does everything we've talked about, except instead of optimizing for performance, it's optimizing for efficiency. And your phone and your laptop and your iPad and your whatever, all of these things are incredible examples of basically turning this whole question on its head. I want to put it to you, is there a chance, or am I nuts, that data centers could similarly be optimized for efficiency instead of optimized for power density?
Well, absolutely. And part of it is if power density is optimizing for efficiency, where if you cut down on the amount of power needed to transmit data across wires, if you cram everything into as tight a space as you can, the amount of energy you use to transmit data between those various different things comes down, and that is why they are trying so hard to get things as dense as possible. And yes, I do think it's important to start optimizing for energy. And Solidigm gave a great talk at the AI Data Infrastructure Field Day last year, where they addressed the problem by taking a look at the total cost of ownership of a data center, and that included replacement costs, energy costs, cooling costs, maintenance costs, and they attempted to demonstrate that these are all factors that you should take into account, not just the performance. And if you look at like the lifetime of a data center or disk or any one of these, typically you spend more maintaining that thing, just powering it and cooling it, than you do initially for the initial cost.
But also to your point, Stephen, about designing things, right? You know, I'm doing a project where I've had storage. I've had spinning disks running in a NAS box for 13 years, right? And it's like
that's my NAS box.
That's your NAS box.
So yours only has 11 years.
11 years, there's 13 years, right? It's scary to have spinning disks running for 13 years. It's time to replace it. And it'd be great if I could replace the spinning disks with low power SSDs, because that I'd love to, you know, cut my power consumption down by, you know, 50%, 100, you know, 90%. But SSDs today are not suitable for the use case because of the properties of non-volatile memory versus the properties of spinning disks.
Well, it depends on how you go about it. And I mean, certainly you can do SSDs at scale. And this is actually something that Jack and I were discussing just a few days ago. We took a quick look at Seagate drives, and between a Seagate 5400 RPM drive and a Seagate 7200 RPM drive, the power consumption was double.
And then you have to ask yourself, we had another Tech Field Day presentation I want to call your attention to. Fujifilm, the tape manufacturers, presented the same picture at Tech Field Day a few years ago, and they were demonstrating just how less power consumption a tape, store a bit on tape is than a disk or an SSD, because it's disconnected. And also they went further into the manufacturing and of those things. They were showing how much less intensive it is to manufacture a tape cartridge as opposed to a disk drive. And it was really interesting to kind of consider all of these aspects, because I think that we're all just so in love with the state of the art, and we're in love with faster, faster, faster. Maybe it doesn't need to be faster, faster, faster.
Yeah. One other aspect too that, I'm going to go a little bit out in the future here. We were talking about small modular reactors, but I am consistently seeing news stories about how companies are actually building the equipment to enable fusion, power transmission, and other things from a fusion site. And there are, again, is this vaporware? I'm not 100% sure, but people are already anticipating that nuclear fusion, not fission, is going to be a thing much more quickly than we would have thought even 25 or 30 years ago. And the implications of what would happen if fusion were available, a clean power source, right? That literally you can take in deuterium from seawater and power immense amounts of anything, what that's going to do. And I think we're much closer to it than we think, right? What is that going to do to this entire factor, right? Or this entire equation? Because Stephen, I know you and I both own EVs, right? The cool thing about an EV is I can put output from my solar panel or my wind generator into a non-ICE vehicle. I can't do that to an F-150 that has an internal combustion engine in it, right?
But you can do that for an F-150 that's an electric.
If it's an Lightning, yes. But so, I mean, this is going to be, if this happens, and the interesting part, because we were at AI Field Day this week, was that there are companies that are using that technology to design the tokamak or whatever model to contain the plasma without having to actually build that. And if we're going to spend money or we're going to burn fossil fuel, let's burn it to power a data center that can get us fusion. I'm looking for an end game, but some sort of high ground.
I think energy and energy consumption is just like storage, whether it's spinning disks, SSDs, or horizontal surface in your house. You will expand to consume all available storage, and we will expand our need for energy to consume all the available energy we can generate. And if we can generate oodles and oodles of energy, we will build oodles and oodles of data center and compute centers and whatever to use that, because we see that that gives us more and more benefits and cool things that we can do. And there's a whole lot of cool things we can do.
Actually, very warm things.
Very warm,
very
really
warm
hot
things.
things that we can
well
do,
done.
right?
And it is a really interesting thought. And I think that, to your point, I mean, I don't know how likely we are to get fusion power. I don't know, I'm not really a believer in small modular reactors either. But that being said, I'm also not going to write them off, because the truth is, this stuff tends to surprise us. Technology tends to improve to the point. I mean, Andy, you and I watched and kind of chuckled at the prospects of solid state storage until we were not laughing anymore, right? I mean, it was pretty pathetic at first, and then suddenly it was not. And it's the same with a lot of this other technology. I mean, the first AI was pretty pathetic, and then suddenly we hit an inflection point, and it does things pretty well.
Yeah.
It's the same with solar. It's the same with a lot of these things. And also another aspect that happens is there's a lot of cross-pollination of technologies. So like electric vehicles gave us improvement, a need for improving battery technology.
Yep.
And that battery technology is now improving the reliability of data center power and the usefulness of solar panels, because you can, we have much, much better batteries than we ever did.
Right.
And so it is really interesting to think about how this, kind of cross-contamination of ideas can actually improve everything.
Yeah, amazing.
So I'd be interested when we actually get to the point where data centers are capable of being run off the DC that you would take directly off a battery. And I mean, I know telephone switching equipment is already that way, but it would make sense that if we actually are going to be able to supply things through like a battery-powered, solar-powered battery, that we should be able to power our electronic equipment directly rather than having to do the AC to DC to.
It's DC to AC to DC, and we do that because we can power the equipment on DC, but we can't transmit the power on
absolutely.
DC, right?
I understand the issue, but it's a matter of doing the transmission. You have to do power transmission, and that goes to the whole idea of running 400-watt buses or 400-volt buses in a rack. Like, are you insane? You're going to kill somebody doing this.
But it is interesting. I do hope that this is a positive thing. Kind of as we're getting to the end of the discussion here, what's your take? Is this a positive prospect or is this a negative prospect? Where are we going?
I think it's an amazing opportunity for cross-pollination of all kinds of things happening. I think the example of the electric battery technology leaping further and further ahead as each year goes by, and finding out that, for example, electric vehicle batteries actually last a heck of a lot longer than anyone ever expected. And the ability to take them, even if they're at end of life for a car, and plug them into an array that you could save that green energy or less dirty energy into, and have it. I mean, that's something that people really didn't think about when this all started.
I think it's very much net positive. I'm a full believer in the future of technology and what it can do for us overall. And if that means, we learned 100, 150 years ago that we are an energy, technology uses energy, and we're an energy consumption environment and energy economy. And we're going to continue that way, whether it's coming from dead dinosaurs or splitting atoms.
Andy?
And I think this harkens back to another discussion that we had previously about did we ask for this? And the answer is no, we didn't really ask for this, but it does present interesting problems that do need to be solved. And in terms of, I see that as a cross between negative and positive, in that yes, it's going to create problems, and at the same time, it's going to create opportunities to solve these problems. From a technology perspective, I see where Jack's coming from, but it's like we are going to have technological problems that we need to address while doing this, and I'm going to call it fairly neutral, but there's going to be both positives and negatives, and it's not something we ask for, but we're going to get it anyway.
And I will put one more thing in there, and that's that if we've seen anything, it's that constraints breed innovation. Whether it is in AI model training, like we've been discussing this week, or electric vehicle batteries, or the development of solar, the development of nuclear power, the development of better, microprocessor, fabrication technologies. If it wasn't for the demand from cell phone industry, which provided all the money in the world, we might not have proceeded so quickly in developing ever better microprocessors. And all of this, like we've talked about, kind of tends to come around and cross-pollinate and improve the situation. And so hopefully the power situation in the data center and the power situation will be improved. At the very least, we will probably come up with new and hopefully better solutions to solve those problems. So thank you for the discussion here. Before we go, where can we connect with you and continue the conversation?
So you can find me on LinkedIn, Jim, I'm going to spell it, CZUPRYNSKI. Don't ask how to pronounce it. Or you can find me at Blue Sky at Jim the Y Guy, Blue Sky Social.
And I'm Jack Poller. You can find me on LinkedIn or at my website, paradigmtechnica.com, or on social media as @Poller, P-O-L-L-E-R.
And I'm Andy Banta. You can find me on social media at Andy Banta and on LinkedIn. And you can go check out my blog at andybanta.substack.com.
And I'm Stephen Foskett. You'll find me at sfoskett on most social media networks, including the Blue Sky and the Mastodon and others. You'll also see me on the Tech Field Day podcast, on the Gestalt IT Rundown, Tech Strong Gang, and actually now we're returning with another season of Utilizing Tech, our Monday podcast. So check that out. We're going to be talking about AI at the edge, and that's going to be a lot of fun. So check that out on your favorite podcast application as well. Thank you for listening to this episode of the Tech Field Day podcast. If you enjoyed it, please do subscribe. You'll find us on YouTube or in your favorite podcast applications, and we would love to hear from you if you want to give us some feedback. The podcast is brought to you by Tech Field Day, home of IT experts from across the industry, and is also brought to you by the Futurum Group, which is our parent company. For upcoming events and more episodes, head over to techfieldday.com/podcast, and you will also find us on TechStrong TV. Look for a new episode every Tuesday. Thanks for listening, and we will catch you soon.